This video is called Real-World Problem Solving with Non-Negative Rational Numbers. Let's take a look at a few problems. Kelsey is a nanny who charges $8.50 an hour for each child ages 3 through 11 years old and makes an extra 25 cents per hour for each child from 6 months to 2 years old. The neighbors have twins aged 1.5 and an 8-year-old. They need Kelsey for 15 hours each week. How much will Kelsey charge them per week? So first determine the variable or variables. Well, we have one variable as the number of children ages 3 to 11, and we have that because that's a certain price. And then we have another variable which is the number of children ages 6 months to 2 years. That's a different price. So now we look at 15 hours. We set up our equation. 15 hours is what they need her for, and that's going to be times the 850x, which is the number of children 3 to 11 is 850 an hour, and then we have plus the 875 per hour for the number of children that are 6 months to 2 years. That should equal the total per week. So we have one 8-year-old, that's our x, that's 1 times $8.50 per hour. And then we have twins. Well, twins means there's 2 children, age 1.5, and that's going to be our y variable. That's times $8.75 per hour. So we have our 15 hours that they need Kelsey per week. We have the $8.50 times the number of children that are 3 years and above. We have 875 times the number of children that are ages 2 and less. So we start by replacing our variables. We have one child, that's our x value, and we have 2 children that are our y value. When we use our order of operations, we know that we need to do what's in parentheses first. So we end up with $8.50 plus $17.50, and then we're going to add those because those are in parentheses. We get 26, and then we multiply that times the 15 hours, and we get $390 per week. Let's look at this problem. Joshua is twice as old as Marie, who is 3 years younger than half the age of Bruce. Bruce is 16 years old. How old are the other 2 children? Well, we know how old Bruce is. We need to know how old Marie is in order to figure out how old Joshua is. So we're going to let the variable x equal Marie's age. And remember, Marie is 3 years younger, minus 3, than half of Bruce's age. And we know that Bruce is 16. So we have our equation set up. So there's our equation again. We're looking for Marie's age. 16 divided by 2 is 8. 8 minus 3 is 5, so Marie is 5. And we know that Joshua is twice Marie's age, so 2 times x, 2 times 5 is Joshua's age. Joshua is 10. So Bruce is 16, Joshua is 10, and Marie is 5. Here's one more problem. You received a cell phone bill for $54.56. You know that the company charges a flat fee of $17.25 and then 7 cents a minute. To the nearest hour, how long did you use your phone? Well, let's let the variable x equal what we're looking for, which is the number of minutes used. So we have our bill, $54.56 is our total, and we know we have a flat fee of $17.25, and we're going to add that to the 7 cents per minute. So here we have our equation. We need to isolate the variable x, and so we're first going to subtract $17.25 from both sides. We come up with 37.31 equals our 7 cents times the minutes per minute. So in order to isolate the variable x, we need to divide by 0.07. And when we do that, we get 533 minutes. Well, the question asked us to put it into hours, to the closest hour. So we need to convert the number of minutes to hours. We know that there are 60 minutes in 1 hour. So we take our minutes, we divide by 60, and we get the number of hours. We end up with 8.83 hours. Well, to the nearest hour, we're going to round up because we have 8, so that's 5 or more. So to the nearest hour, 9 hours is our answer. All right, this is the end of this brief little video on problem solving real world problems, and hope you enjoy the activity.